Oh. I was just ready to yell at the IT department. There it goes. Okay. So, who's going to help with fat absorption? First of all, who's going to help digest fats? There's two players, because there's two steps. Gallbladder is going to help to what? Emulsify. So remember my little exciting drawing on the board? It's going to help break the lipid molecules apart. And then who's going to break the lipid molecule down? What enzymes? Lipase. Who's going to help with that? Pancreas. Okay. So there's some other guys that secrete it. There's some in saliva, some in the stomach, but they're not really going to do us very good. The most effective is going to happen in the small intestine with the help of the pancreas. Now, absorption doesn't happen directly into the circulatory system. We have to kind of take a side road through the lymphatic system and create little packages called myceles. They're made up of fatty acids, monoglycerides, and bile salts. What's a monoglyceride? What's fat? What are fats made of?
Fatty acid
and glycerol. Okay, so these little packages are aglycerol, fatty acids, and a little bile salts to help us get those absorbed. Those fatty acids and monoglycerides are going to leave the myceles and diffuse into the, and I'm reading right from here because that's exactly the best description I can give you. Diffuse into the epithelial cells. What epithelial cells? Where are we talking about? Small intestines, the linings of the villi. Remember, if I look at the histology of the small intestine, I see those little extensions, those villi. And what's running up those little fingers?
What's running?
Yeah, what's inside the villi?
There's lymph nodes.
Lymphatic vessels and blood vessels, arteries and veins. So that's what we're looking at right here. The epithelial cells we're talking about are the epithelial cells that line the villi. What kind of epithelial cells? Simple, columnar, and they have those little microvilli on them, again, to increase surface area. So they're going to enter in there and create another little package of substances called a chylomicron. So we're going to repackage them with the help of a little protein. Why do you think we need to add a protein to our lipids? Not break it down, but to travel. Travel where?
Blood.
In all that liquid, all that water. And why do we need to add the protein? Because lipids are hydrophobic. If I didn't have a carrier of some kind to pull them along, they would just stick to the sides. They wouldn't get into the fluids and wouldn't get into the lymphatics and wouldn't travel to the circulatory system. So those extra little packages we have to create to put them into the lacteal, which is part of the lymphatic system, is called a chylomicron. Once I created that little protein combination, then I can travel through fluids, get back into the circulatory system via the same routes that we saw when we discussed the lymphatic system. Everybody with me? So first I have to go into the lymphatic system if I'm lipids. That's my extra step. And I have to be carried by a protein because I'm hydrophobic. This diagram talks about the absorption of who? Monosaccharide, exactly, sugars. So the book goes on to talk about breakdown of nucleic acids, the enzymes, again on that chart that I told you to know. The absorption of different things will happen with the help of different protein ATPases or protein receptors on the surface of cells. We call them ATPases because they take energy to work. So they are like enzymes because they're protein in nature, and they're going to help with transport and absorption of different substances. So there's several different diagrams in the book that show us some of the different ATPases or proteins that are going to help with the absorption of some of these different molecules. So we see this guy with the help of some sodium ions in the absorption of carbohydrates, glucose, galactose. Again, I'm not going to get crazy about that. I just want you to understand that there are very specific receptors responsible for the absorption of the different substances in our digestive process. So I want us to be familiar with each of the organic compounds. I want you to understand what enzymes are responsible for breaking them into their simple building blocks. So you have to dust off your chemistry brain from last semester and remember, what are they made of? Carbohydrates are made of simple sugars. Proteins are made of amino acids. Lipids, glycerol, fatty acids, and then nucleic acids are building blocks of little nucleotides.
So we don't have to memorize the
I'm not going to make you
transport mechanisms that involve the
No. Just understand that
part.
diagram with the enzymes, who makes it, how it works, who it works on. Okay? Vitamin electrolyte absorption, we talked about that being lower down in the large intestine. There are some important transition molecules that talk a little bit about something called ferritin. Ferritin, Fe. Who's a chemist? Yeah, iron. So they talk a little bit about ferritin transport here as well. And iron is important to build what? When you think iron, what's the most famous molecule you should think? Hemoglobin molecule. Okay? And that's, again, that is housed in the red blood cells. Also, water absorption. We take in water, but through reactions of metabolism, we also make water. So equal water balance in all of our different fluid compartments, and we'll talk about that in chapter, I think it's 27, Fluid and Electrolytes, is extremely important. In the digestive process, water is important to help dissolve molecules, but water is also going to help transport some of these molecules into the circulatory system as well. So we'll see that some of these reactions are going to also produce water. We're going to talk in a moment about a reaction called cellular respiration. All of this water that is produced by metabolism is called metabolic water. So they make a little mention of some of the different water involved in the gastrointestinal tract, and we'll talk more in detail about that when we discuss chapter 27, Fluid and Electrolytes. So we'll talk about how the body balances those out. Diseases that disrupt this whole process, this cellular process, that damage the cells, or disrupt the ion balance, or disrupt the pH, can fall into a category, a broad category of diseases called malabsorption diseases. And we talked a little bit about some celiac disease. Any sensitivities or hypersensitivities or allergies to food can actually disrupt or destroy the lining of the small intestine or the stomach or somewhere in the gastrointestinal tract. There's so many different examples.
Genetic factor that
There could be genetic factors as well. Yep.
but usually it's something that
Not necessarily. It could be genetic factors. It could be a disease state that causes damage. It could be environmental factors that cause you to become hypersensitive to things too. So it's a huge, broad category of malabsorptive diseases. It's not necessarily just one thing.
Okay, so if, for example, you never had a celiac disease in your early years, and then you find out that when you're 50 or something you have celiac disease, is it possible?
Usually if it's celiac disease, you would probably find out earlier in life. But if you have an insensitivity to gluten, that's something that you can develop as with age. Yeah, it kind of ends up in the same result, with the same results, but for different reasons. Okay? And what...
Actually, they were talking about this on the Today Show this morning, how all these food allergies are produced by us because of the way we eat. But like other countries don't have like these peanut allergies, and gluten-free is kind of bad unless you have that disease.
Yeah, but there are sensitivities to foods, so it's not really a fad. We see it more because, and you said it, that we created, exactly. So there's a lot of schools of thought that think the alteration of some of our vegetable matter, genetically modified foods, highly processed foods, breeding foods to be the gluten we talk about when we talk about celiac disease, it's not the same gluten as it was 30 years ago. It's a much more hardy molecule.
Right, because they were saying you find gluten in a lot more things than like just bread now, like you find
And it's changed.
yeah.
So our systems might not be meant, exactly. It's a much larger, more hardy molecule. So maybe our bodies weren't meant to deal with it in that form. So take my nutrition class. We'll talk about it in more detail. But yeah, there's a whole bunch, the whole categories, and the stuff that we put in our food. The dyes, the preservatives, the artificial sweeteners are so bad for our systems. And they do, they can change. Remember, environmental, not only do you express your genetic material, but environmental factors can also have an effect on how you express your genetic material.
Your kids are little. One of the questions was, should you not allow them to eat all these things like peanuts and stuff that they could be allergic to? And they said that the opposite is true. You should make them eat it. And then you introduce it, one at a time.
Right. That's the key. You have to make sure you don't bombard the system, but you should, if you introduce it slowly, one at a time, and that's kind of a thing that we've learned through the years, not to just bombard the system with all these different things. Then, exactly, yeah. So waiting too long, not waiting long enough, there's so many different factors that can affect. And environmental. So are some of the chemicals we use on our food, the preservatives, the hormones, what else? What else do we throw all over our food that's scary? The preservatives, chemicals. But what else? I go to the farm, I get an apple, yum! Pesticides. And that might be a big reason why we start to see all this. So that's a whole realm of research that is kind of difficult to pinpoint an answer to, but those are some of the things that have changed in the way we eat from, our great-grandparents to us now. And do those things have a profound effect on how our body deals with these things? I say yes. Yes? All right. So, Kentucky Fried Chicken. By the way, I have to tell you about my dinner last night. Since we're on this part of the chapter, which talks about diet and nutrition, we've seen this probably 1,000 times in our life, and it changes. It's changed 1,000 times in our life. Why do you think it changes so much?
Because new factors find out.
Nutrition as a science is a very new science. When you take anatomy and physiology, pretty much everything's the same. So I look at a book 30 years ago, pretty much everything's the same. There's a few things that are different, new things we've discovered. But when I look at a nutrition book, I'm going to find a huge variety, and I'm going to find many, many, many different things in many, many, many different books, because it's a very new science. But I think that we all agree that we need, after going through the digestive system and discussing all of these different components, we need certain amounts of certain components to build our molecules so that we can maintain homeostasis. we need so many carbohydrates, and we need so many proteins, and we need so many lipids, and we need so many nucleic acids to make our own molecules. I think we're all in agreement there. As far as how much of everything, we're still not so much in agreement. But this food pyramid is a basis of how much we should put into our systems to get the molecules that we need to build the molecules that we need. So diet and nutrition is just touched on a little bit in the textbook. There's a whole bunch of information out there. There's a place called My Pyramid, which is changed. Now we're changing stuff because we say, well, people are more visual. They want to see something that makes sense to them. So they've created this other option to go look and see how we should balance our diet in a day. And that's called myplate.gov. And that gives us a general guideline for eating certain materials so we can get the molecules we need to build the molecules we need. On page 909 in the textbook, we see some of the different ones and some of the different recommendations. Okay, I have two stories. I cannot lose weight to save my life. I've been exercising and I've been doing all kinds of good things, and that scale doesn't go down. Holy moly. Just a warning to you young people, your metabolism goes to hell when you get old. So I was concerned. Something's wrong. You know, the scientist in me comes out. Something's wrong. Something's wrong. Da, 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 da. So I said, well, you know what? I think I need to start monitoring my caloric intake because maybe I'm getting a little bit more calories than I think I'm getting, even though I'm eating healthy. So I started using a little, it's called MyFitnessPal. It's a little app on your phone. Isn't that the most awesome? It's great. It's wonderful. So I reinforce to myself that I'm eating fine, I'm eating healthy, I'm doing okay with the calories. So last night I was lazy and I decided I didn't want to make dinner. But I said I was going to order out and I was going to order healthy dinner. So I felt like meat. So I got a piece of steak and a baked potato with no butter, just the potato, and some wonderful steamed broccoli. Do you know how many grams of fat there is in 6 ounces of ribeye steak?
500.
You say 10?
About 500.
No, it's not that bad, Mila. We're not sucking on a thing of butter.
No. I mean
Grams of fat.
grams of fat, not calorie. I'm sorry. I
No.
thought calorie.
No.
About
Think
500 calories.
think of grams of fat. 8, 10,
I would say maybe 50. Close to 50.
25, 63.
I was close.
Holy crap!
I was close.
No, it's a ribeye steak. Now, here's where you have to be careful. Meat is not so bad, but you have to pick your meat properly. Now, if you get, the most expensive, the filet mignon, lovely, very lean, not so bad. Ribeye, not so good. Because when you buy a ribeye steak, have you ever bought one? What's that? Oh, yeah, huge. I know. No. But here I am, being so good at my little numbers, all my numbers, and I still was within my calorie range. But I thought, oh my God, 63? I never thought it was 63.
So you ordered
Not
your
bad for
dinner
just the meat.
with the nutritional information?
I order it with, I actually do that sometimes if I'm going to order something.
My husband's like, just order.
Just
Please,
eat it.
Order.
Well, you can just eat it. Me, I gotta watch out.
I'm just saying when you don't watch yourself once, twice, then it's becoming habit. And you don't
And
watch
then you
it
have
at
to,
all, and then you
expand. So I just would like to share that information with you. According to the pyramid, was that okay? Well, no. It was delicious.
Did it fall into the right size portion on your plate?
Yes.
See, so then it was good.
Yeah, but still. I was very mad when I saw my numbers. So when you look at the food pyramid, you see different food groups, different servings of food groups, and then my plate sort of does the same thing, except it shows it to you on a plate. So what should most of your plate be?
Vegetables, fruits,
Yeah,
grains.
these guys. Grains, no. Quarter, half. Yes? So most of your plate should be vegetables. Do most of us eat that way? Try.
Okay, I don't really have a voice.
Uh-oh, you're losing your voice? Ah!
I'm sure you're all happy. My mother-in-law lost over 100 pounds, and she went to a nutritionist. I mean, at my wedding, she was probably like 230. She's down to 135 pounds.
Wow.
And it took her about 5 months to do it.
Wow, that's fast.
Yeah, and it's because she checked it every 2 weeks. She went on the scale. I told her about my fitness pal because I discovered it.
Yeah,
And she just, it tells you like what kind of calories that you should be, what your average is, about what you do every day, and you know, if you still work or whatever.
exactly.
So she based it on that, and then she also cut all the soda. She cut out all her fruits. She cut out all
fruits.
the meat. She had strictly vegetables.
Oh,
And then after she got to her goal weight, she slowly incorporated fruits again because fruits are so high in
Sugar.
that that's what was causing her to like gain a lot of weight. So she would do like Greek yogurt, like plain Greek yogurt. She still got a little bit of dietary, you know, milk and stuff, but it was
Yep.
so white.
Yep.
It was all good for her. And then once she lost the weight, she just
Slowly incorporated.
She's maintained it for 7 years.
wow. Good for her.
So, you know, I pick her apart when we go out to eat because she's like, what's on that? She like, we go to Olive Garden, she's like, I need to have the breadsticks without the butter and
Yeah.
stuff on it.
Yeah.
She's very good about everything, but she'll have like a bite of cake, like the
Yeah.
birthday, or she'll have like a little spoonful of cake. But I think very highly of her.
Yeah.
Getting as far as she's gotten paid that way. It's so hard.
Oh, yeah.
To be around that stuff.
Constantly. And then it's the bad habits that get you there. Yeah. Or eats too much, and the thing, I think the thing that we should all keep in mind is we need all of these things. So when a fad diet comes out and says, no this, no that, no carbohydrates, no protein, no, don't pay attention. Remember your mindset that you have to have everything. You need proteins, you need fats, you need carbohydrates. Bless you. You need all of these substances to keep a healthful you. Exactly. Portion control. Because it's built-in portion control. Exactly. And then say what? And exercise. That's part of it. So when you look at the pyramid, one of the things that has changed on the pyramid is there's steps going up the side and there's someone running up the stairs, because we also realize a healthful diet not only includes eating healthful foods, but also including exercise as well. So that's important to keep you healthy. You need, yeah, and one of the things, for somebody who's morbidly obese, for example, don't get caught up with the numbers. Change the habits. One step at a time. Yeah. Well, that's and again, that's a little extreme. I mean, they're wonderful things. Exactly. So think in moderation.
Losers that they when they're there at the camp, that's not really a lifestyle for them. That's their lifestyle for 6 weeks or however long they're there. But most people on an everyday can't spend 6 to 8 hours exercising, and they don't have
Correct.
a chef at home preparing their meals for them, down to the exact calorie
so
count.
true.
Yep.
So,
And that's what I mean. When you decide to change, if you have bad habits, you need to change them in baby steps. You know, you need to incorporate.
There's another show. I watch. I don't have TV at home. I don't watch TV at all. But when I'm in the Planet Fitness, they have.
Oh, they have the TVs.
And there is a show. I don't know even how it's called, but there's a man, and he's actually, I think he's like a psychologist.
Just.
And he's just training people, not just saying, oh, 6 weeks, and I will just put you in a strict diet, and I will just, take all of the juice from you, so you will be, tiny.
Yeah, it's the habit. It's those habits you have to
he's
change.
Working in, psychological with those people, and this one girl, she was overweighted, probably 13, 14 years old, and she was seeing him for, I don't know for how long, but she lost weight, but she keeps this weight the same because she just changed her lifestyle completely, and she's very active in life, and
Right.
This became her lifestyle.
Exactly.
Not just like a show, 6 weeks and then.
Yeah.
slow down.
And it's like I say with anything, even like when we talk about habits like smoking, there's so many other factors involved in the habit, and overeating is a habit that we acquire. So we, little by little change small things, and those are things that will hopefully last.
In my psychology class, they said that a lot of people's overeating nowadays is more due to parents not worrying that their kids are eating enough because they aren't eating the same amounts of them, so they're
Right. Yeah. And we teach our kids, exactly. Or we put servings on our kids' plates that are way too big for them. Gosh, in my household back in the day, clean plate club, clean your plate, don't waste anything. Yeah.
Yeah, and if you didn't
With
eat
my
it,
mother, with my daughter, my 3-year-old daughter,
She'd do the same thing.
freezer, and my mother will be like, she hasn't eaten, she needs to eat more than that. And I said, no. She eats when she's hungry.
Yep.
She knows how to open the refrigerator. We have a whole area that she has some healthy snacks, and
Yep.
she knows where to get food when she's hungry.
And that's smart because, what do? We turn around and say, okay, you have to eat at 7, at 12, you have to eat then, and don't eat in between, and It's like that's the worst way to eat. We're better off having smaller meals.
Like, we'll eat, a meat, vegetables, and usually sometimes start, and my daughter doesn't even care for that. She's like, no, I want a snack. Because her snack is sliced cheese with grapes and celery, you know what I mean? It's like, this is what
Yeah,
we
she's
do.
a grazer, and that's the best way to
Yeah,
eat.
I just want that. So I keep telling people, I'm like, I need to eat more like my
Yeah, yeah.
3.
My 2-year-old, she's 3-year-old.
Yeah, and the thing to always keep in mind is to, however you choose to eat, that smaller meals more often, that's a better way to eat because our bodies can do what better? Digest it, absorb it, utilize it. That's the key. When we sit down and we have a 2,000 calorie meal, you get tired, you get sluggish. Is your digestive system going to be able to handle all that? No. So your digestive process is not efficient. So the thing to keep in mind with nutrition, and again, there's tons of different books and tons of different schools, but if you just keep in mind the things that we need to get in and about percentage of what we need to get in of each, that's going to help us stick to a healthful diet. So carbohydrates, when we talk about calorie intake, there's tons of different programs. That program that we just mentioned, you can go in and enter all kinds of information about yourself, how much you weigh, your age, your height. It'll give you ideas of where you should be weight range-wise. And then it'll give you ideas for how to get there. So at a certain weight, you can eat so many calories. And then as you decrease in weight, what's going to happen to you? You decrease your calories.
Like when you count the things you eat, how you count the grams?
The program,
ounces, or
Yep, you scan it in.
Scale everything? No, you scan it.
Or you weigh it. Yeah.
If I prepare food home, where I can...
You
scan
do an estimate. So what I do is if I make homemade chicken soup, for example. So I'll go into the program and pick, a low sodium chicken stock, and I'll pick, 3 ounces of chicken, and I'll pick, carrots and something. So yeah, you have to do it all separate. You can do homemade stuff sometimes.
And I'll do that, because
Yeah.
I cook a lot of homemade stuff, so I just go in and make my own recipes, and then when I go back,
You can put them in your program. The one I showed you in nutrition class, you could do that too. There's another one, it's called, I can't think of the name of it. Calorie counters or something.
I have a...
But it's a nice one because you can do that too. You can do your home recipes and break things down.
I do,
But keep in the ballpark.
I do Weight Watchers, and it's a similar idea.
Yep.
I have an app on my phone. It's more, geared towards points, which factors in the fat, the fiber, the protein.
Correct.
And bases points based on that.
Yeah. And if you work that system properly and you like to eat food, what you're going to do is use your points wisely.
Right. And that's
Correct.
That's what
And
they
that's
teach
the
you.
exactly.
But the thing is that they've revamped their program. I don't know if you're familiar with it before, but now fruits are 0. So you can,
Oh, wow.
you can eat fruits and
Yeah, but see,
vegetables.
there's a lot,
Fruits
and that's,
vegetables are all 0 except for your starchy vegetables like corn.
Yeah.
Isn't 0, but anything, you can eat grapes and bananas and
Yeah. Say fruits, yeah, because fruits tend to be high in sugar. So if you stick to this general, and again, you're going to see different numbers everywhere. But if you're in the ballpark, and that's one of the things we also have to realize is we can't be psychotic about everything we put in our mouths either. No, go ahead and eat like a pig. It's okay to have a Reese's peanut butter cup every once in a while. Yes? The problem comes when we do what?
When you deprive yourself.
Eat the whole bag of Reese's peanut butter cups, right?
It's too, with most people, if you deprive yourself, I've tried the no carb, and after 4 days, then I eat every carb in sight because
Correct.
I'm eating
Plus, is it good for you to not have, what do we want for carbohydrates? And do you know how to figure out percent? Let me show you a quick calculation. Say I do 2,000 calories a day, and that's the average. Another thing, ladies and gentlemen who's not here today, who want to lose weight, when you deprive yourself of the calories you need for regular metabolism, what happens to your metabolism? It slows down. Counterproductive. So sometimes when you get stuck, you're just not eating enough calories. So say average 2,000 calories. Well, to figure out how much we should get of each, this says to me here, recommended for carbohydrates is 45, and I don't have a calculator, to 65%. So this is out of 100, right? What do we have for lipids?
20 to 35.
Yep, 20 to 35% of your calories should be from lipids. We want our lipids to be unsaturated, not saturated. We'll talk about that in a minute. Proteins, how much? Okay, so these are the 3 calorie molecules. So this one, carbohydrates, 4 calories with a big C per gram. This guy here, lipids, 9 calories per gram. And this guy here, proteins, 4 calories per gram. Okay? So of your 2,000 calories, say I choose, and you can go and, kind of design a diet that says, okay, I think, carbohydrates are kind of drive me over the edge. So instead of saying at the 65, maybe I'll go more towards the 45%. Say I choose something in the middle, 50%. So if I multiply this by 0.5, what do I get? 1,000, right? So 1,000 of my calories of my 2,000 that I get per day are going to come from carbohydrates. How many grams of carbohydrates is that? So what do I do?
1,000,
Divided by 4. So what's the number? 250 grams.
Well,
Yep, 250 because 4 goes in. Yep. So 250 grams of carbohydrates. Okay, so if you're going to count a nutrient, carbohydrates, 250. Today I was at the gym and I told the guy that helps me out at the gym about my scary little steak. The 63 grams. He's like, oh, you're only supposed to have 20 grams of fat a day. I'm like, really? No. He goes, yeah. I said, no.
saturated maybe.
No. I mean, I don't know what he was thinking. Maybe he was thinking this %, but that's not right. So if I chose 20% from my lipids, I'd do this, 2,000 times 0.2, right? And what would that give me?
400?
2 was before time, what is it, 400?
400, yeah.
Yep. Divided by what?
By
9. What's 400 divided by 9?
44.4.
Yeah. 44 point something,
About
right?
45 grams.
Yeah, so about 45 grams of fat. I'm like, I knew then. I said, Bob, that's way too low. He's like, no, it's not. I'm like, yeah, it is. So now I have to go show him the problem. So
You Bob, Biggest Losers, you treated.
no, no. So that's how you kind of, if you're counting something or using programs like this, or going on Weight Watchers, they've done all this work for you. They say you have so many points, and typically you can't fit. Like, you're not going to go and take your 27 points or whatever you have for the day and blow it on Snickers bars, are you? You can,
Yeah, no,
but then you get nothing else to eat, right? Except for the Snicker bars. So you learn that to use your points wisely.
Don't they have a new point system too on Weight Watchers where if you do so many exercise, you get so many points?
Right. And basically, in the Fitness Pal program, yep,
We'll give you more calories if we're doing
to maintain. So if you're looking to maintain your weight, the bottom line is calories in versus calories out. Calories or kilocalories are a measurement of heat energy that food gives us. So when they talk about energy and energy molecule, they're talking about the calories, or these are actually kilocalories, 1,000 calories that you see on your nutrition labels. So you don't have any calories in there. But what's the C look like? Yep. Is it a big C or is it a little c? When they say calories. It's a big C. That's kilocalories. So 1 calorie is the amount of heat it takes to raise 1 gram of water 1 degree Celsius. So this is the chemistry part of all this nonsense. A kilocalorie, huh?
This is the part I don't.
Yeah, the part nobody likes. But I hate to say it, but it's all chemistry too. So that's what those calories are. And again, based on your body size, your gender. Who can have more calories? Men. Not fair. They have a higher metabolic rate. I know. It's a good thing he's not. He's going to listen to the tape and go, oh, it's a good thing I wasn't there with all those women. They have a larger muscle mass on average. That's why they get more calories, because muscle uses up more energy that's provided by the calories that we eat.
Like we have a hot tub, and so like my boyfriend can sit in the hot tub and just relax, and I float.
Or you have to leave because you get way too hot. You
Yes.
float.
I do. Like I can't just sit there. Like I have to like hold myself down. Is that because they're more muscular?
Correct.
Okay.
And their bones tend to be more dense because they're more muscular. So they're
I
denser.
never figured
Males
that out.
are denser than females. And the other thing lucky females have that are less dense, yes, they're much more dense. More fat. There's 2 kinds of fat. There's white fat and brown fat.
Yeah.
Brown fat is more surface fat, and infants tend to have a higher percentage of brown fat, and males tend to have a higher percentage of brown fat. That's why they're so hot all the time.
But isn't it true?
Heat.
I'm trying to debate because I know we need to learn, but I took health and wellness with Dr. Steen.
Yeah.
And the biggest thing I learned, which I did awesome when I was in his class, was accountability, because we did the logs, and every week we had to go in and talk to him about it. But we really did focus on calories more so than we did the proteins and the fibers. And so
Yep.
the calorie content could be really high, but I was actually losing weight because of the extra protein. And I was
Correct.
putting a whole
Because
bunch
you
of
were
awesome
putting
stuff.
things in proportion better.
Yeah, I felt amazing, and now I don't.
No, we'll keep doing that.
No, but-
So what's up here on the board? I know we are getting so sidetracked.
Nutrition's fun to talk
I know it is. That's why you have to take my nutrition class. So this talks about something called amino acids. What do they make up? Proteins. How much protein should we have a day? No. Yeah. 12 to 20%. Yes? Okay. And again, you do the math depending on what calories you need. Like I get more calories than you do because you're little and I'm big. So I get more. Haha. So it depends on how many calories you should eat in a day and what you want to do. You want to maintain your weight? Do you want to lose weight?
I don't remember how you calculate how many calories.
It's a big, huge body metabolic index. But you can go on any program and quick and easy find that answer.
Your height, weight, and age.
Exactly. And gender.
Right.
And then
Tells you.
and your activity level too is typically a question they ask too. So it's important for us to get all the building blocks we need, and this is most important. Well, not most important, but it's high up there on the priority list. Getting all the amino acids you need in the foods that you eat to produce your proteins. And one of the things that people might be lacking is getting the right protein combinations in. One of the hardest things for a vegetarian, for example, is to get all of the amino acids that they need. Now, it's not that hard. It just takes a little education. So if I never, ever, ever eat meat, can I be a healthy individual? Absolutely. But I have to do a little more homework when it comes to eating the foods based on the content of amino acids. When I eat meat, it's a no-brainer because meat is what I am. It comes from animals. That's what I'm made of. It's very similar. So meat has all the amino acids that I need to build my proteins. So we sometimes refer to it as a complete protein. I call it the no-brainer protein. I don't have to think about it. But if I choose to eat vegetables, I can still do that. But I have to combine different foods to make sure I get all of the amino acids I need. Now, I don't have to get every single one of them, because believe it or not, I can make some of them. But some of them I can't make. And what do we call those amino acids?
Essentials.
Yeah, we call them essential amino acids because I can't make them myself. I have to eat them. So here they list 8 essential amino acids. You have to combine different foods sometimes. And when a really popular meal for vegetarian countries and countries that tend to eat more on the vegetarian side, what's a real popular meal for them? Not even tofu. Rice and beans. So you look at some of these countries that have a primarily vegetarian diet, and rice and bean dishes are very popular in their menu. So the combination of those foods helps to give us all of the amino acids we need. So it's important that we get all the essential amino acids, the ones we can't make on our own, in the proteins that we eat. And again, being a meat eater, it's a no-brainer. I'm going to get them. So you just have to be a little bit more conscious of what you're eating and combinations of what you're eating when you choose not to eat that protein source.
Can I ask you a question?
Yeah.
It says that water is major nutrition.
Water is
Major
yeah.
nutrition.
Yeah.
Is it true?
Oh, yeah.
But why before that they're saying that only three nutritions are
Our
major?
calorie molecules.
Carbohydrate, protein, and lipid. And then they're saying that actually water is major nutrition.
Try to live without water.
No, I know.
But that's why it's in there.
Just what they say in book.
No, that's what they mean. That is, when we think of chemistry in general, Without water, it can't happen.
No, of course.
Exactly. So that's why they group it in that category.
Maybe they were talking about ones that,
Major nutrient.
yeah, that have calories, because water has no calories.
Yes.
Right.
But it's in the first,
Yep.
on the first page.
And it's important, you know, without water and certain percentage of water, none of this can happen. So that's why it's grouped there. As far as calories goes, these are the three guys that are going to provide us with that heat energy that we measure in calories.
Define how many proteins are essential? 11 or how many?
8.
Total.
How many amino acids? 8.
8?
8 or 9, it depends on the book you read, but 8 is what we have in our book. And those are called essential amino acids. It says 10 in the book.
Yes. So that's why I'm asking. So 8 or 10?
Let's go. Let's stick in the middle. Let's go 9.
So 8 to 10.
Let's say let's say 9 essential amino acids. That's a real popular thing as well. Again, see, you know, everybody gets on my tail about the numbers, and that's why sometimes I don't get crazy about the numbers.
Fun fact that she read.
Yes, fun fact.
Fun fact says that it says that 2 of them are only infants. That's why it says 10, but we only have kids.
Aha.
So
8. 8. 9, 10. Okay? So, the other thing that's important for us and our metabolism is not only the building block stuff, but the stuff that's going to help with the reactions of metabolism. So even though these aren't calorie molecules, they're not going to provide us with any energy, they're vital for us and our metabolism, the chemistry that needs to take place in metabolism. And that group of molecules are called vitamins. There's different groups of vitamins. Some vitamins are water-soluble vitamins. Some vitamins are fat-soluble vitamins. So remember that diet where you're not supposed to eat any fat? No fat. You can eat all you want, but no fat. Because fat makes you fat, right? Yeah, no. But what's the problem with not getting enough fat in your diet? You can't absorb properly some of these fat-soluble vitamins. What else? What is fat in our bodies? Well, fat gives us energy. We can use it to make energy in the reaction of cellular respiratory protection. Yep. Yep, protection in general. You're missing the biggest one.
plasma membrane.
Yeah, every single cell in your body is made of a phospholipid bilayer. What else? And this is one molecule that gets a bad rep all the time. Cholesterol. It's actually a major building material for your cells. It's so important that your body makes its own. Sometimes we're genetically predisposed to make a little bit too much, and that might cause some problems, cholesterol issues.
See on the news today the cool thing about genetic mapping that you can get it done for $99.
Yep. I know my husband came home, I'm going to get genetic. I'm like, yeah, no. I don't want to know.
I just thought that was really cool. I'm like, who would have thought that it would be like so cheap? You'd think that that would cost like thousands of dollars.
Oh, yeah. Well, technology, you know.
The problem with that, though, is that eventually insurance companies are going to be grabbing onto that, and like, couldn't they use that as a way to increase your insurance rate?
Yeah, because you're predisposed for certain diseases.
I can probably bet you I have 99% chance that my genetic mapping shows Alzheimer's disease because of a long line history of my family. I can only imagine my insurance company having a heyday with that one.
Yeah.
Obamacare will help us.
Or if you can get on the website, right?
If you can get on the website. Okay, come on, we're getting sidetracked here. All right, so list on page 912, table 24.2, lists some of these different vitamins. And these are essential for reactions of metabolism. In this list, they tell us where we can get them from and sort of what they do in the body. I'm not going to make you memorize them, but it's there for your information. why these are important. Water-soluble, fat-soluble vitamins. When you eat a healthful diet, you follow the My Plate or My Pyramid and get all those different combinations of stuff you're supposed to get. For the most part, you're going to get most of the vitamins you need as well. Sometimes you might be lacking in a few things here and there. And what's one of the things that you can do to help that out? Take a vitamin supplement. What does the word supplement mean? In addition to, not in place of. Have any of you ever done this? I'm going to buy all these different vitamins, and I'm going to take them, and I'm not going to eat. Well, back in my day, that was kind of the craze. You know, I'll take my vitamins and I'll skip my meals. But vitamins are what we call coenzymes. They are going to help with reactions of metabolism. If you don't have anything for them to help with, what are you going to do with them? You're going to get rid of them, exactly, especially the water-soluble vitamins. So if you take vitamins and you don't eat, what do you have? You have expensive urine. Yes, that's what you've got.
Maybe for water-soluble, that will cause some effect, but if it's fat-soluble...
But if you don't eat anything, how are you gonna absorb the fat-soluble vitamins?
No, that's what I'm trying to say, that fat-soluble, you will not be able to absorb them, but water-soluble you can, right?
Right, so you have expensive stool.
Yeah.
Yes? You're going to pass them. You're not going to use them. Some of the fat-soluble vitamins you can store for a little bit longer. One of the ones that I do recommend you take is vitamin D. One of the things that we up here in the Northeast now this time of year experiences a lower period of sun exposure. And one of the things that vitamin D helps with is things like blood clotting and things like that. Kind of important. Yeah, we're starting with it already. So, symptoms of deficiencies, and that's what's neat about this chart. Shows you when you have a vitamin D deficiency. You might start feeling a little sluggish in the old brain. Do some of you feel like that in the winter? Like, oh my God, I can't even focus. Take a vitamin D supplement, it might help. Cardiovascular and kidney damage is also listed there as well. So these vitamins are important for reactions of metabolism.
The cardiovascular, brain, and kidney damage, so that's where you have too much, right?
Well, you can have too much or too little, right?
Okay, because the pink one said that it was...
Correct. So too much or too little can cause issues. Deficiencies usually rickets, which is a bone disease of younger children. Vitamin D is important. You know why vitamin D is important? To help absorb calcium, exactly. And calcium, there's another big market supplement, yes? Tons of people think, oh, my bones are going to fall apart. I need to take calcium supplements. You don't really. As you get older, if you're predisposed for certain things, if you take proton pump inhibitors. Because one of the things you have to realize is there's a certain absorption rate. So you know we talk about the 12 feet and the, whatever 21 feet of small intestine. You can only absorb a certain amount in that period of time. So when you take supplements that have like 2,000 milligrams of something, what do you do with the excess? You get rid of it. And usually it has to be in the right form in order for it to be absorbed properly. And many times those supplements aren't in the right form. And I think I mentioned to you guys the Citracal versus, yeah.
So if we're going to take, like, for example, I was taking biotin for a while because I have, like, terrible nails. They break, crack. And they say you can take, like, up to, like, 5,000 milligrams in a day. But, so if you were going to take even, like, say, 2,000, would it be smart to take, like, 1,000 in the morning and 1,000 at night? Or, like,
any supplement, it's better that you take it in smaller doses. Calcium's better. if you take it 3 times, 4 times a day. Who's going to remember to do that, though? That's
Well, I know, but
It's
it,
only got a baby,
yeah.
but it takes over.
Yeah. So, yeah, she's not going to take her calcium supplements 4 times a day.
yeah, but if you, I mean, if you were.
Yes, it's
if
better
you-
in
if you
smaller
took one,
amounts.
You know, even if you took one first thing in the morning and then one right before bed.
Correct. Yep. Huh? You're just going to pass it. And then that taxes who? Overworks who? The kidneys, because they have to filter that stuff out. So who knows? Might cause more damage long term. Not only do they talk a little bit about vitamins, but they also talk about minerals. Things like iron and copper. Believe it or not, those are important. They're important minerals for reactions of metabolism. So when you take a vitamin supplement, typically most vitamin supplements nowadays are not only vitamins, but they're also minerals too. And we get small, and it's very small amounts of those, so you don't have to take tons and tons. All right, this is the scary part of the chapter, the part you've all been waiting for, metabolic reactions. So taking these guys and putting them into chemistry, breaking them apart, altering them for different reasons is what we talk about here under overview of metabolic reactions. Now there's 2 categories of reactions. We can either break things apart or we can put things together. When we take in the cheeseburger, we're going to do both of these things. We're going to break it apart into its building blocks, the amino acids, the carbohydrates, the lipids, the glycerol, the fatty acid. Those reactions that break things apart are called catabolic reactions or catabolism. After I've broken them apart, I need to take them, bring some of them into the cell, and do what with them? Use them to make my molecules, right? The carbohydrate guys that I broke down, I'm going to use in this reaction, in this series of reactions called cellular respiration. What is the goal of cellular respiration? Energy, making ATP, adenosine triphosphate. I'm going to alter those molecules to make adenosine triphosphate. Again, that reaction is called, one of the metabolic reactions is called cellular respiration. The other thing I might do with some of those building blocks, like proteins, for example. What did I break proteins down into? Amino acids. Then what am I going to do with them? Create my own proteins. So what do I do with them? How do I do that?
Take the different amino acids and follow the instruction from DNA.
Exactly. Remember way back when, again, brushing off the brain, I would think it was chapter 3 or chapter 2, we talked about transcription and translation. It's when we talked about cells. So we take the amino acids that we broke down from the cheeseburger and we put them together. Those reactions are called what? Anabolic reactions. So anabolism and catabolism combined is what we're going to discuss when we discuss reactions of metabolism. Breaking things down, building things up. When I break things apart, they typically give off more energy than it takes for the reaction to occur. When I build things up, it typically takes more energy to do that. So there's 2 other terms that you probably can dust off the brain and remember. Does anybody know what they are? Endergonic and exergonic. Okay, exergonic reactions, more energy exits. So which reaction is exergonic?
Exergonic is what, did you say?
Releases more energy than takes to happen. Gives off energy.
Anabolism.
The other one, catabolism. Okay, and then taking more energy, endergonic, would be who? Anabolism. So sometimes you'll see those terms sort of used interchangeably. They all sort of mean the same thing. No, that came from my brain.
Okay. Can you repeat that again?
Well, just remember anabolism and catabolism.
Okay, so
Give off energy, take up energy. And that's exergonic is, you can write beside which reaction? Catabolism. And endergonic is anabolism.
So you said anabolism gives energy, metabolism takes energy?
No. Anabolism takes energy. No, takes more energy to happen. So when I have an anabolic reaction, for example, protein synthesis is an anabolic reaction, I need more energy in order for it to take place. The opposite for catabolism. It's going to give off more energy than it takes. Yes? And that's repeat from chapter 2 when we discussed chemistry. All right, this reaction here, I know you remember everything from chapter 2, don't you? This is kind of the basis of the rest of this chapter. This is the watered down version of cellular respiration. The main player in cellular respiration, the thing that's going to give me the most ATP, the best bang for my buck, is the guy in the center. Which molecule is that? Carbohydrate. Sometimes when we talk about cellular respiration, it's referred to as the metabolism of glucose, the breaking down of simple sugars. So glucose and other sugars, simple sugars, enter this reaction, and see why we stick carbohydrates down the middle, because that's the most direct route for the entire reaction. It consists of the beginning part where I take the molecule and start to break it apart. That part is called glycolysis. Glycolysis. Make sense? Break down. What's lyse mean? Break, right? Glycolysis. Breakdown of glucose. We're going to produce a molecule from that called pyruvic acid. And we're going to use that molecule to form this molecule called acetyl coenzyme A. Now that molecule is then going to enter another series of long reactions called the Krebs cycle. This part of the reaction takes place in the mitochondria of the cell. So in the mitochondria of the cell, this is where we're going to produce lots and lots of what? ATP. That's why, remember when we talked about the cell way back in chapter 3, sometimes we refer to the mitochondria as what? The powerhouse of the cell. Now we know why, because this is where this chemistry takes place. So the Krebs cycle then produces substances that bring electrons to the last part of the reaction. The last part of the reaction is called a couple of different things. In your diagram, we see it referred to as oxidative phosphorylation. We also see it referred to as the electron transport chain. Because through a series of membranes, we're going to take electrons in the form of hydrogen ions and pump them through these little membrane proteins we see in the mitochondria. That's going to give me energy to take phosphorus and stick it onto ADP, adenosine diphosphate, and create lots and lots and lots of what? ATP.
What means phosphorus?
Add phosphorus. Add phosphorus too.
Add phosphorus.
Correct. So ATP, adenosine triphosphate, is also a nucleic acid. You remember what nucleic acids were made of?
Yeah, phosphate, nucleic base, sugar,
Correct. So when we talk about adenosine triphosphate, the nitrogenous base is what? Adenine. Remember adenine, guanine, thymine, cytosine, those friends we met in the DNA molecule? Yes? And what's the sugar? Ribose, and then we have 3 of phosphate groups, triphosphate. When I break one phosphate group off, I release energy. Yes? That's why that's my energy molecule. So when I make energy, I'm making this. I break that to release the energy. What do I need energy for? Yeah, all these reactions of metabolism I keep talking about. I need energy to drive them. Carbohydrates is the best bang for my buck, but that's not the only thing I can use. The other molecules, those calorie molecules I was talking about, I can use them too. But I don't get the best bang for my buck. And the other thing I might get is some waste products that I'm going to have to deal with. So amino acids, typically, what do I want to use those for? Do I want to use them to make energy? No. What do I want to use my amino acids for?
Your DNA.
Yeah, protein, not DNA.
Oh, right.
Proteins. I want to make my muscles. I want to make all those protein receptors that are hanging out in my cells. I want to make antibodies. I want to make enzymes. I don't want to use my amino acids to make energy, do I? Yeah. So, but I can. I can break apart some of those amino acids and use them in different parts of the reaction.
How cold if you make energy from protein or make glucose?
Oh, gluconeogenesis?
Yeah.
Yep, that's in there too. Making new glucose. So we can use other molecules to work in the reaction. We can also use fatty acids and glycerol in different places. So we can use lipids as well. We saw we actually get more energy from lipids, don't we?
Yeah.
And it actually is a great thing to use. But it's hard to break apart and use to make my ATP. And certain tissues in my body don't like to use ATP made from fats. Do you know who doesn't like to use ATP made from fats? No, that is adipose tissue. That's where I store it. Who doesn't like to use energy made from fats?
Brain.
Your brain, your central nervous system. It wants energy made from carbohydrates. So you know that great diet where you eat all the bacon and you know, meat and awesome diet, you lose weight, it falls off your body. What's one of the things that really is a problem?
Degrading your brain.
Yeah.
Depriving your brain of
Yeah.
the energy.
You lose focus, you get tired a lot. Yeah, you look great, but you can't think. So again, you know, that even balance.
They say like models are dumb.
Yeah, but they don't eat bacon. Oh God, they don't.
But they don't
Okay.
eat carbs either.
No, they don't eat anything. All right, so combinations of reactions within cellular respiration are going to help produce ATP. And I'll leave you with oxidation reduction reactions. These happen hand in hand so often we group them into a category called redox reactions. And they always go hand in hand. So oxidation and reduction, again, we're dusting off the chemistry brain because you learned this already in Chapter 2 last semester. What was the difference between the reactions? Oxidation reactions, we lose electrons. Reduction reaction, we gain electrons. So you see why they always go hand in hand? They always work together. When somebody loses an electron from oxidation, it's picked up by a reduction reaction. So when we talk about oxidative phosphorylation at the bottom, we see these reactions happening hand in hand. We usually call them...
Losing electrons
Well, it's a series of redox reactions, oxidation reduction reactions. And that's going to, yeah, both of them are in oxidative phosphorylation. So we will pick up with oxidation reduction reactions. I highly suggest you read this chapter before we come to class, but I will warn you, you might feel a tad overwhelmed. And I will tell you that I am not going to make you memorize all of the different portions of this reaction. I'll give you an example.
What do you mean?
When you get, this is kind of the basis of what I want you to know. When you get into each of the reactions, what you're going to see is all of the different manipulations of the molecules, all of the different reactions associated with that glycolysis. I don't want you to memorize that. I want you to know that glycolysis is the breaking of glucose, and then the result is what we get at the bottom. Okay, so we're going to make pyruvic acid. We're going to also make some electron carriers that we'll talk about,
So
and that's going to go to the next step.
The first part of the text and the last part of the text. Right?
Pretty much. And let me, see the figure 24.12 on page 924. You need to know that whole thing. Okay?
Can you say it again?
Figure 24.12 on page 924. You need to know that. So basically it's what's going into the reaction, what's coming out of the reaction with respect to molecules that are necessary for the next part of the reactions to take place.
Were you going to send us an email with the possible essay questions? Did you want to pass on the test again?
Huh?
Did you want to pass on the test? Did she say somebody should write?
Oh yeah!
Did you say that again?
Let me pass out the tests.